Good afternoon, class. We are looking at exam 3 review covering chapters 3, differentiation rules, chapter 4, application of differentiations, which covers from 3.9 to 3.11, 4.1 to 4.5, and we are going to look at section 4.1, maximum and minimum values, and the mean value theorem. So 4.1, maximum and minimum values, 4.2, the mean value theorem. First, section 4.1, maximum and minimum values, definition of a CP, critical point. A critical number or point of a function f is a number C such that f prime is either 0 or f prime DNE does not exist. So the procedure is to find f prime of x first, then set f prime of x equal to 0 and find the values. Set f prime of x to DNE. That normally happens when you have a fractional form where the denominator is 0 and the expression is undefined or does not exist. For example, we want to find the critical numbers for this function f of x equals x to the power of minus 2 ln x. We are going to differentiate this first. So the derivative in this case, we use the product rule. So I'm going to write the product rule, reminding you it's f prime g plus g prime f. Therefore, the derivative of x to the power of minus 2 is minus 2x to the power of minus 3 times ln x, plus the derivative of ln x is 1 over x times x to the power of negative 2. And all you have to do is simplify this. So this one, we write it again. And this one, I hope you realize the last two is really the same as x to the power of negative 3. If I factor out x to the power of negative 3, I get negative 2 ln x from the first one and 1 from the next one. To set this equal 3 equals 0, it's better to take this down and write down f prime is 0. A fraction is 0 when the top is 0. F prime doesn't exist when the bottom is 0. So f prime equals 0 makes negative 2 ln x plus 1 equal to 0. So again, a fraction is 0 when the top is 0. Therefore, ln x is 1/2, and x is, remember the arrow, x is e to the power of 1/2 precisely, or square root of e. If prime doesn't exist, you set the denominator equal to 0, and you get x equals 0. However, it can't be. Why not? Because when you go back to the original function is the product of ln x and x to the power of minus 2, or 1 over x squared, and the domain according to ln x is from 0 to infinity. According to this one would be all real numbers except x. So it's not in the domain. 0 is not in the domain, everybody. And so we are going to move on. So why I mentioned it's not in the domain, okay? The domain for this one, again, let me just write that for you. So this class, ln x over x squared, and the domain is 0 to infinity. Why? ln x, the domain is 0 to infinity. For any fractional expression, you set the denominator equal to 0 and exclude it. For that part, 1 over x squared in case, okay, the domain is all real numbers except 0. All right, formal definition of a maximum and minimum. Local or relative extreme values. Extrema is the plural of the Latin extremum. A local minimum is the minimum value within some open interval. Local minimum occurs at a point C in an open interval of A to B. in the domain if f of c is less than equal to less than or equal to f of x for all x values in the open interval. So this is your local mean. A local max is the maximum value within some open interval. Local max occurs at the point C in an open interval of a to b in the domain if f of c is larger than or equal to f of x for all x values in that open interval. So let's go back up here. Local mean, local max. Local mean, local max. Okay, in some open interval. But why is it local? If this is the local mean, there are points that have a smaller y coordinates. If this is local max, there are points that have a larger y coordinate. Whereas absolute or global refers to the entire domain. Therefore, absolute or global extreme values of or extrema are either maximum or minimum points on a curve. Absolute minimum occurs at the point C if f of c is less than or equal to f of x for all, and that's the key, all x values in the domain. So as you can see, I want you to recognize peaks and valleys are your local extremum. So local mean, local max, this is the local mean. It so happened to be an absolute mean as well. Absolute maximum occurs at the point C if f of c is larger than or equal to f of x for all x values in the domain. So again, local max, local mean, local max. This local max is an absolute max because no other point has a larger y coordinate. We want to find the absolute max and minimum value of the function of the given interval where f of x is equal to 1/3 x cubed minus 9x and the given interval is minus 6 to 0. This is called extreme value or closed interval theorem. This is a polynomial of degree 3. So again, the terminology is extreme value or closed interval theorem. Closed interval theorem says if you happen to have a continuous function in a closed interval, then it attains an absolute max as well as absolute mean. Now, this is a polynomial of degree 3. Domain is all real numbers. Therefore, it's continuous not only in there, also in the given interval of negative 6 to 0. So what is the procedure? The procedure is find f prime of x first. Let's do that. This gives you 1/3 times 3x squared or simply x squared minus 9. So that's f prime. The procedure says set it equal to 0 and solve. Let's do that. To do that, we do the factoring. X plus 3x minus 3. And when we set it equal to 0, there are two answers. This gives you negative 3, this gives you positive 3. The procedure says also look for f prime not exist. F prime does not exist, doesn't produce any solution because itself is a polynomial of degree 2. This is a Greek letter phi, which represents an empty set. It's not a 0, everybody. Now, what you must check are these two numbers in the given interval. Negative 3 is in between, yes. Is 3 in between? No. The only thing you can use is negative 3. So that's step 1. What is step 2? Find f of a, that means f of minus 6. Find f of b, that means 0. Let me just write this. This is a comma b, okay? F of C1, C2, however many critical points. We have only one critical point. So we are going to find f of a or minus 6, f of b or 0, and f of the critical point or minus 3. I'm going to give you the answers. I'm going to quickly show you how fast you can. Zero is very simple. You plug in, you get zero. Minus 6, how do you evaluate it? Put it into this function, okay? Into this function. So this is 1/3 minus 6 cubed minus 9 times minus 6. You do the math, you get minus 18. For negative 3, we get 1/3 negative 3 cubed minus 9 times negative. Now, which one is largest? The largest number, 18. So absolute max is 18 at this pair. Smallest, negative 18. Absolute min is negative 18 at this pair. Of course, the way you answer the question, however they ask you, you answer it accordingly. Let's look at another example to make sure we master this. We want to find the absolute max and mean value of this function f of x equals x plus 3 to the power of 2/3 minus 5 in the interval of minus 4 to 5. So what type of a function do we have? That's the question. So x plus 3 to the power of 2/3 means cube root of x plus 3 quantity squared minus 5. So what do we have? We have a cube root that is being squared and then minus 5. So what about the cube root? We should know the domain is all real numbers. So we have a cube root, the domain is all real numbers. Therefore, it's continuous everywhere from negative 4 to 5. It's continuous from negative infinity to positive infinity. Therefore, negative 4 to 5 is not a problem. So let's find f prime of x. 2/3 x plus 3 to the power of 2/3 minus 1 or negative 1/3 times the derivative of the inside 1. So I'm assuming we have no problem with the differentiation. And so this becomes 2/3 times x plus 3 to the power of 1/3. The next one is to look at two things. F prime is 0, f prime doesn't exist, and find values. F prime is 0. That means the fraction is 0. A fraction in the form of a over b is 0 when the top is 0, the numerator, a. And it's undefined or does not exist when b is 0. So it's 0 if the numerator is 0. Since numerator is a number, it doesn't matter big, small, fraction, decimal, there is no solutions. This means no solutions. F prime does not exist, or it's undefined when the bottom is 0. And the bottom is only 0 if x is negative 3. Is negative 3 in the given interval? Yes. So we are to evaluate the function at a, which is negative 4, at b, which is 5, and at negative 3, which is the critical point. It's easier to put it into this. So if I put negative 4 in here, everybody, negative 4. Negative 4 and 3 is what? Negative 1. So I'm going to write down, if I put negative 4, I get cube root of negative 1. I square it. Okay. Well, let me just put it further down because I need that space. So Cube root of -1 is -1. Square it becomes +1. 1 minus 5 is -4. I'm going to show you how to get the rest of them as well. So if I put -3 here, everybody, -3 here, becomes 0. So it's -5. If I put 5, 5 and 3 is 8. So let me show you 5. If I put 5, 5 and 3 is 8. Cube root of 8, 2. Square is 4. Minus 5 is -1. So it's very easy, everybody. And so all of them are negative. Believe it or not, this is the largest value. So absolute minimum is -1 at this pair. This is the smallest value. Absolute minimum is this, -5 at this pair. This is how I like to write it, but you want to pay attention to the way they ask the question. Okay, everybody? So you want to be very careful as they ask the question. Let's look at another example. We want to find the absolute max and mean value for this function f of x of which is x over x squared plus 2. And please understand this is a closed interval. So we are going to use the extreme value or closed interval theorem. First, what type of a function? Anybody knows the name of this function? This is a rational function. Rational functions, generally speaking, let me just give you an example, such as 1 over x minus 1. You set the denominator equal to 0, x equals 1, and you say the domain is everything except 1. And the way you write it is minus infinity, 1 union 1 to infinity, right? That's rational functions. However, in this case, the denominator x squared plus 2 equals 0, this has no solutions because x squared plus 2 is always positive. In fact, it's larger than equal, larger or equal to 2. So although it's a rational function, everybody, its domain is all real numbers because there is no restriction. Therefore, it's also continuous in the given interval of 0 to 4. I need this space, so I'm going to clean up the mess. We need to differentiate, so I'm going to say this is f over g, and I need f prime g minus g prime f over g squared, the quotient root. Therefore, I need f prime 1 times x squared plus 2 minus 2x times x, right? The derivative of the bottom times x over the bottom in a parentheses and square it. And believe it or not, this is the one and only calculus step, okay? Everything else becomes algebra. The numerator can be simplified as follows. These two can be combined into minus x squared. And f prime is 0. That means the numerator is 0. And x is plus minus square root of 2. F prime doesn't exist. That means the bottom is 0. And we've already proved x squared plus 2 can't be 0. Even if you square it or to any other power can't be. So this doesn't create any solutions. And so is Square root of 2 in between. Square root of 2 is 1.41. Yes. Is minus square root of 2 in between? No. So only square root of 2. So we are going to plug in A, B, and C. A is 0, B is 4, and C is square root of 2 into this original function. If I plug in 0, it's 0 over 2. So this gives you 0. What about the rest of it? Let me quickly show you. If I put square root of 2 here, I get square root of 2 over square root of 2 squared plus 2, which is square root of 2 over 2 plus 2, which is square root of 2 over 4. What if I put 4? I get 4 over 4 squared plus 2. 4 squared is 16, plus 2 is 18. So 4 over 18, which is 2 over 9. And you may recognize that this is larger than this because square root of 2 is about 1.41. If you double up the bottom, you get almost 9, it's 8. And if you double up this one, you get 2.81. So this is larger, but you can go with the decimal representation. So absolute max is this value at this pair. Absolute min is 0 at this pair. All right? Very straightforward, everybody. Find the absolute max and mean for this function in the given interval. So first and foremost, this is a polynomial of degree 2 times 3. Please understand this is a polynomial of degree 2 times 3 or 6, which makes it continuous from negative to positive infinity, and therefore it's continuous in the given interval of -1 to 2. Okay, therefore it makes it continuous from the interval of -1 to 2. Let's find f prime of x. So f prime of x, that's what we want to do. 3 times x squared minus 1 squared times the derivative of the inside, the 2x. We are going to set this equal to 0. And when you set this equal to 0, class, obviously, if I were to rewrite it, and you don't have to, but 6x is different color. Let's write it up here. 6x times x squared minus 1 is 0. This gives you x equals 0. This gives you x squared equals 1, which is plus minus 1. So there are 3 answers. -1 is in between. -1 is one of the endpoints. 0 and 1 are in between, yes. So we evaluate the function at the endpoints -1 and 2, as well as the critical points 0 and 1. So, for example, if I plug in -1 here, when I square it becomes +1 with this cancels each other. This becomes 0. Believe it or not, this becomes 0 also. 0 gives you -1 cubed, which is -1. And if I plug in 2, 2 squared, 4 minus 1, 3 cubed is 27. So it's a very easy math, everybody. Okay. So largest value is 27, absolute max at this pair. Smallest value is -1, absolute mean at this pair. So very straightforward, everybody. All right. Section 4.2, the mean value theorem. We're going to start with Rolle's theorem. Let f be a function that satisfies the following. Number one, f is continuous on the closed interval of a to b. Number two, f is differentiable on the open interval of a to b. Number three, f of a equals f of b. If so, then there is a number c between a and b such that f prime of c equal to 0. Graphs of some typical functions that satisfy the three hypotheses are given. Okay. When we say f prime of c is 0, that means at some point we have a tangent line which is horizontal. This means horizontal tangent line at some point. In each case, it appears that there is at least one point c comma f of c on the graph where the tangent is horizontal, and therefore f prime of c equals 0. That's the meaning of it. So let f of x equals x to the power of 4 minus 2x squared. Find all c in the interval of -2 to 2 such that f prime of x equals 0. Reminding you that Rolle's theorem has three parts or hypotheses. Three hypotheses. F must be continuous in the closed interval of a to b, differentiable in the open interval. The endpoints must result in the same functional value. F of a must be equal to f of b. In that case, there is a c which is an element of, remember we've discussed that, is an element of AB such that f prime of c equals 0. So that's very straightforward, everybody. So what type of a function is this? It's a polynomial of degree 4. Therefore, the first two are satisfied. Because we know it's a polynomial, f is continuous from negative to positive infinity, therefore it's continuous from negative. Since they gave us this, we go with the closed one for the continuity. And it's differentiable in the given interval of, open interval of -2 to 2. So these two are the direct effect of being a polynomial. Polynomials have no problems. They are continuous. They are differentiable everywhere. So all we have to do, look at the endpoints, -2 and 2, and evaluate the function. So I need to calculate f of -2. So what is f of -2? -2 to the power of 4, -2 times -2 squared. That's what it is, right? -2 to the power of 4, -2 times -2 squared. And you may notice that this is 16. This one is 4 minus 2 is 8. The answer is 8. What about f of 2? If I plug in 2 2 to the power of 4. If I plug in 2 here, I also get 8 because 2 to the power of 4 minus 2 times 2 squared. That is the same thing, 16 minus 8. So let's go back to the Rolle's theorem. First one, is f continuous from negative 2 to 2, some a and b? Yes. Closed interval. Is it differentiable? Yes. Is f of a equals to f of b? That means f of minus 2 and 2 are the same. You have to prove that by proving it that they are equal to some number. You are going to come up with that number. Therefore, there must be a c such that f prime of c must be 0. So how do you find that? You find f prime of x and you set it equal to 0 and you solve it. So what is f prime of x? 4x cubed minus 4x. To set this equal to 0, we have to factor out the 4x. You know this gives you 0 and this gives you x squared equals 1 or plus minus 1. And by the way, the 4 in front is a multiplier. If it's 4 or 4,000 or minus 2 or any other number, it has no bearing. So there are 3 answers. We are interested in the ones that belong to this interval. All of them are in that interval. Therefore, in the interval of negative 2 to 2, the derivative is 0 at each of these 3x values. F prime is 0. In other words, f prime of negative 1 is 0. F prime of 0 is 0. F prime of 1 is 0. If we were to graph this, everybody, and you can use a graphing calculator. It looks like that. Remember x to the power of 4, so the end behavior. And so it looks like that. We are interested from negative 2 to 2. So at negative 2, it's 8, right? As at 2 is 8. First, take a look at this one, this point, and this point. They are referring to these points that we got. So between negative 2 and 2, and the 2 are identical. This point, this point, this point. Those are negative 1, 0, and 1. And look, over here, horizontal tangent line, horizontal tangent line, horizontal tangent line. So at 3 points, x equals negative 1, x equals 0, and x equals 1, we do have f prime equal to 0 or horizontal tangent line. All we need is 1, but we happen to have 3 because what the theorem explains that there is a number such that f prime is 0. It doesn't say how many, okay? We happen to have more than 1. This was the Rolle's theorem. Now, Rolle's theorem is the special case of a mean value theorem. So the mean value theorem has only 2 of those hypotheses. Let f be a function that satisfies size. F is continuous in the closed interval of a to b. F is differentiable on the open interval of a to b. Remember, the Rolle's theorem had the third case where it says f of a equals f of b. We no longer have that. Then what happens? Then there is a number c in the interval such that f prime of c equals f of b minus f of a over b minus a. Now, what is this? If you have 2 pairs, this represents the slope. And what are those 2 pairs representing? A secant line. So take a look. Here's some graph. Here's some point. Here's another point. Those are A and B. And what we are claiming is this is a continuous function and a differentiable function. So what does this represent, everybody? This is a secant line. This is the slope of the secant line. So what we are saying, somewhere in between, there is a tangent line which is parallel to the secant line. We are looking to find that point. We are looking for that point. Now, this is AF of A. This is BF of B. And again, when you calculate, this becomes the slope of a secant line. Okay, everybody? F of B minus F of A over B minus A represents slope of the secant line. In other words, there is a point P where the tangent line is parallel to the secant line AB. So here's the secant line AB. Here's parallel to that. Okay. That's what the mean value theorem is all about. So F is continuous. So the mean value theorem says if F is continuous in the closed interval of A to B, F is differentiable in the open interval of A to B, there is a number C in AB such that F prime of C is F of B minus F of A over B minus A. If you do the cross product, gives you this. I hope you realize these two are equivalent. Okay, class? These two are pretty much the same. The mean value theorem. Given that f of x is 5 minus 4 over x, that's some function, find all c in the interval of 1 to 4 such that the slope of the secant line equals the slope of a tangent line. That's the mean value theorem. So 5 minus 4 over x, that is a rational function, and you can graph it easily. You can do it by hand or use a calculator. Okay. And so what happens is that you can discuss the continuity differentiability by looking at the domain and so forth. And I hope you realize x can't be 0. Okay. The domain is all real numbers except 0. Okay. So first, here's number 1 and number 4, class. Here's number 1. Here's number 4. So number 1 corresponds to this point on the graph. Number 4 corresponds to this point on the graph. If you draw a secant line, it looks like that. We are looking for a tangent line that is parallel to that between 1 and 4. By the way, there is another one that is parallel to that here, but we just want it between 1 and 4. Okay, so there's one more in case. We want it just in this interval. And again, I want to make sure that everybody understands that the domain for this function is x can't be 0 or minus infinity 0 union 0 to infinity. So it's continuous everywhere except 0, therefore it makes it continuous in that interval. And so this is the question mark, everybody. This is what we are looking for. F is a rational function. Therefore, it's continuous everywhere except 0. And therefore, it's continuous in what we want, 1 to 4. It is also differentiable then. So, according to this, there must be a point C such that f of b minus f of a over b minus a is equal to f prime of C. So f of a 4 minus f of a 1, f of 4 minus f of 1 over 4 minus 1. So f prime of C, or you can say even f prime of x, doesn't matter because we are going to solve that. So what is f of a 4? If I plug in 4 here, this becomes 1. 5 minus that is 4. If I plug in 1 here, becomes 4. 5 minus 4 is 1. I'm assuming everybody can see that f of 4 is 4, f of 1 is So you have 3 over 3 or 1. So f prime of x, let's say, is 1. Find x. So you have to find f prime of x. And f prime of x, I hope you see that minus 4 over x. Let me just write this for you here, just in case. So f of x is 5 minus 4 x to the power of minus 1. So f prime is minus 4 times minus 1 times x to the power minus 2, or positive 4 over x squared. And we are going to set this equal to 1 to find x. Cross product, x squared equals 4, and x is plus minus 2. But remember, we just wanted between 1 and 4. I told you there are two answers. So the choice is x or c equals 2. Again, why is that? It's between 1 and 4, okay? We want this number to be between these two numbers, and negative 2 is outside. That's why. So I'm going to write it as, because 2 is an element of 0 to 4. The set of 0 to 4. All right. Let's look at this question. Suppose f prime of x is between 3 and 5 for all x. Show that f of 8 minus f of 2 is between 18 and 30. We're going to use the mean value theorem on that. So when we look at this concept, okay, f of 8 minus f of 2, that means f of a b minus f of a, and therefore a is 2, b is 8. We should recognize that. Now remember what we want. We want continuity and differentiability. And they both are satisfied. Why is that? Here's the given class. When we say f prime is between 3 and 5, that means f prime does exist. If the value of f prime exists, that means f is differentiable. And if it's differentiable, it's continuous as well. Not the other way around, by the way. So both of this is because of this statement, everybody. This statement is given. This says the function is differentiable, and therefore, so this is resulting in this one. If it's differentiable, it's also continuous, not the other way around. So we are going to write, and we figured out A and B. So this is closed, this is open. Therefore, the mean value theorem applies. This is true for all x, everybody. Let's write it. This is true for all x, right? So f prime of x is always between 3 and 5. So is f prime of c. If f prime of x is between 3 and 5, f prime of any point which we don't have, doesn't matter what it is, which we are going to write it in this fashion, is between 3 and 5. F prime of x, that means any value of x. So this f prime of c, we know it to be f of b minus f of b minus f of a over b minus a. So we are going to look at this part only. Now 8 minus 2 is what? 6. And we're going to multiply all sides by number 6. This becomes 18. 6 goes away. 5 times 6, 30. And believe it or not, this is the proof, everybody. So we were supposed to show that f of 8 minus f of 2 is between 18 and 30. And that's exactly what we have here.